Hi everybody, this is episode 2 where I recreated the snake game. In this episode we're going to first do some refactoring to make the code a bit nicer, and then we're going to add the functionality to make the snake grow. Somewhere in this video I will make a coding mistake which I don't catch immediately. Can you spot it before I do? Comment below. We will start by creating a snake class, so we can put all the functionality related to the snake into this class. This means we're going to put the position of the snake head and the direction it's traveling at into the class. Furthermore, we're going to put the calculate next state into the snake class, but we're going to put it in a different method. Let's call it move, for example. This means that in our main class we're going to create a new snake object, and we're going to initialize it in the constructor. I think it would be a good idea to give it an initial position, so let's put those coordinates in the snake constructor as parameters. And in IntelliJ we can nicely assign the parameters to actual fields in the class. Instead of using a direction as an int, it would be nicer to use the direction as an enumeration, so let's create that. Now let's change the type of the direction field, and the default will be direction right. We don't need to initialize this x and y here because they're initialized in the constructor. And now the switch of the direction should actually have a different case. It would be up, down, right and left. Back into the snake game class, we need to change the directions. Since we don't have them here, we need to change the direction in the snake object itself. So for that, we would need to do something like set direction. We don't have a method set direction, so let's create it. Then we modify the other directions the same way. One thing pops in mind already. We should only be able to set a direction if certain conditions are true. For example, if the snake goes to the left, to my left, then we cannot just set direction to go back right onto itself. Let's call this direction new direction, and we can do a switch on the direction here. What I'm basically doing here is I'm checking if the current direction is up, then only set the direction to new direction if that new direction is not down. So I'm going to do the same for the other cases. In case we're traveling down currently, we can set the direction only if the new direction is not up. If snake is traveling to the right, then we set only if it's not traveling to the left currently. This looks pretty good. Back into the snake game class, we need to take care of these two x and y variables, which we don't have here anymore. That means we need to create getters for the x and y in the snake class, so we can retrieve the actual values. However, I don't really like that. I would rather have the x and y inside a struct or a position class, so that when we retrieve them together and we don't have to have individual calls for different x and different y's. Also, this will help us in the future when we're going to make the body of the snake grow. What we have here is a simple position class which contains the two variables x and y as integers, a constructor with parameters to initialize them, and then two getters. Back into the snake class, let's modify the constructor to accept a position. Let's call it head. This will be the head of the snake. Instead of these two variables, x and y, we need to think a bit what we're going to have here. So the snake, as it grows, will have more and more parts in the body. So we can code them as positions. The very first time when we create a snake, it's only going to contain one little character, so we can call that the head. But as the snake grows, we need to be able to add more of those characters into the body of the snake. This implies that we need to have a data structure here which can grow. What comes to mind initially is a list. Maybe a list is good, let's see. Which means if we are going to create a new snake, we're going to add the head position into this new empty list. And then as the snake grows, we're going to add more and more positions into the body. Back in the snake game, we need to create our snake not with these two coordinates anymore, but with an actual position. So for that, we're going to create inside here new position. And in here, we're going to put the X and Y. In the paint head, we need the position of the head of the snake. So we can do that here. These are the row first and then the column. Get Y first and then get X. We don't have this get head method, so let's create it. Head is always going to be the first element in the body. Body get 0. We still need to fix this missing X and Y coordinates when we remove the snake from the screen, but this has to be the tail of the snake. The reason for this is that when the snake travels, when we want to remove the last element, it's going to be always at the position of the tail of the snake. We don't have a getTail method, so let's just create it. What we return here is the last position in the body of the snake. What we need to do next is move the snake in the calculate next state. And let's see how the snake moves now. The move method of the snake is a bit trickier, because as the snake moves, the head will go to a new position on the screen. That means we're going to create a new head position based on the previous head position, only translated according to the direction of the snake. This means that if the snake is going up, then we're going to create a new head as a new position of the same X coordinate, but with Y minus 1 of the previous head. Then we add this new head into the tip of the body. This becomes basically the new head. And at the same time, we remove the tail, so we remove the last element in the body list. Let's also specify that the right direction is also the default. Okay, the code compiles. Let's see how it works. Go to right, down, left, up. So it seems to work properly. Let's try to go down. Oh, this should not happen. So there's something wrong with setting the directions. If I go up, I should not be able to go down immediately. Left, go. If I go left, I cannot go right. Okay, so there's something definitely wrong with the checks that I'm making when the direction changes. So let's see, what have I done wrong here? There it is. A rookie mistake. I forgot the break. So my cases were actually bleeding, cascading from one to another without a break in there. I should probably cut this out so I'm not embarrassing myself. Let's run it again. Down, up, doesn't work, good. Left, right, doesn't work. Up, if I press down, doesn't work, good. So this now works as expected. So, just to recap, we have done a bit of code cleanup. We moved things around into their own classes. we have a snake class which contains a list of positions, which is the body of the snake. We have the move method. We have the setting of directions. We check if the new direction is a valid direction. Everything seems to be working fine now. Next, let's make the snake grow. Let's add the grow functionality. For that, we're going to create a new method called grow, which takes a parameter, which is going to be the amount. How much do we want that snake to grow with? The way I'm thinking about the grow functionality is that as the snake head moves, if it grows, then we should not remove items from the tail of the snake. So just let the head move and it grows without removing the tail. This means that if we have a grow variable, which is the amount of how much it will grow, we decrease that variable by 1 for each movement of the snake. The moment the grow reaches 0, then we're going to start removing positions from the tail as the snake moves. In the move method, we need to check the value of the grow variable and only remove the tail if the grow is 0. Otherwise, we simply decrease the grow by 1. In the snake game, in the constructor, let's make the snake grow when we first create it by amount of, I don't know, 20, let's say. Okay, let's see how this looks like. Aha, there you go. We should start seeing the move. Yes, there it is. If we go down, the new heads are added. If it goes over its body, nothing happens. Basically, there's no checks on collision yet. It actually just removes the part of its body. This is all I have for today. In the next video, we're going to add some collision and boundary checks. If you find this content interesting, please give it a like, subscribe, and ring the bell so you get a notification next time I upload a new video. Bye for now!